Hello everyone. Today I will explain what data center accelerator and why they are essential for AI training, the main types and how they speed up training plus real world use and future trends. First we can see the what is data center accelerator. Normally accelerator is a specialized chip or card designed to perform the heavy math used in machine learning, especially matrix multiplication and complex problem and tensor operations. Unlike a general CPU, accelerators are built to run many operations in parallel. That's why modern data centers use them to train large AI model much faster. You guys are know CPU is the normally operator small operations and normally we have to know that, and this this can be runs parallel operations of AI modules and also used in cloud platforms and hyperscale data centers. You have next topic why accelerators for training. Training deep learning models requires huge compute and memory bandwidth. We know a model with million or billion of parameter can take weeks on CPU. Accelerators cut that down to days or hours only. So many operations are once and moving data faster between memory and compute units. So CPU it can be take a weeks on operate the operation, but this can be operated days and hours only. So accelerators reduce training time for complex of operations to solve easily weeks to hours. Next topic types of data center accelerators. Normally we know GPU and CPU and FPGA ASIC. GPU is the most commonly used. TPU Google purpose built chip and then FPGA reprogrammable logic and ASIC is the custom fixed function. Each has trade in flexibility, perform energy efficient and cost. Next we can see the CPU and GPU difference. CPU we know central processing unit, GPU we know graphics processing unit. CPU execute the arithmetic and logic operations and are handling complex instruction and task switching, and also it have a lower core count and also focusing on delivering high performance for tasks that rely on a single core, but GPU has them parallelly processing multiple operations and equally executing the answers. That's why GPU uses a specialized type of DRAM known as the VRAM, and also specialized designed to handle graphical data and structures. So GPU is efficient way of the processing of complex operations. Next we can see the first type of the data center accelerators. First one is GPUs for AI training. GPU have the thousands of small cores designed for parallel math. So GPU commonly used to operating a parallel maths, and also they are great for framework like PyTorch and TensorFlow. And also modern GPU also include tensor core optimized for matrix math used in neutral net and high bandwidth memory to move data quickly. So what here to know means GPU is a highly parallel architecture and also used in PyTorch TensorFlow and also excellent for matrix multiplication and deep learning. This is the one of the GPU NVIDIA A100 and H100. Here the H100 is the huge amount of operations can be processed. Next we can see the TPU for AI training. This is the one of the Google designed AI chip, and also this also optimized for TensorFlow and also large scale training, and it give a high throughput, and also it can be used in Google Cloud. They are tightly integrated with TensorFlow and optimized for the high throughput. This is the workflow of the tensor processing unit. We can see the first Google application. It can give the TensorFlow and Google application. It makes a execute the AI operation and user space driver and kernel driver. Last one is the tensor processing unit. The whole three is the TPU stack. This is the image of the TPU Google Tensor processing unit. Next we can see the FPGA and ASIG. FPGA are the reprogrammable. You can implement custom data path optimized for a model. This can be, we can customize which operation when it done, why it can happen like that, we can be customized, and also which is useful for some interference or specialized training task, that the FPGA. And then one ASIC is the fixed task and also extremely power efficient but lack of flexibility. Here the FPGA is the customer programmable chip. It is the picture of this FPGA. Next we can see the key features of accelerators. Normally we know the accelerators is a high memory bandwidth, so it can be easy to use, and also tensor core matrix multiplication engine, it have low latency interconnect and also power efficient operations. So example NVLink or custom fabric. This can be specialized tensor unit for matrix operation and also low latency interconnect, and also energy efficient design. It can be easy to processing of the heavy operation. So the key features of accelerators is the mostly move data efficiently and also compute quickly, which is the bottleneck in training. Next we can see the how accelerator boosts training speed. We know there are four main things: parallelize the computations across many cores, provide hardware for fast tensor operations, enable mixed precision to speed math with computable accuracy, and supported distributed training across many devices with fast interactions. So here hardware optimized operations, and also it can be easily execute the parallel operations, so it can be efficient of and also boost up the training speed. Next, applications in real world. uh, we know ChatGPT is the one of the best source of that, and also LLM training, computer vision, image video processing, recommender system, and automated vehicle stacks. We know the automated car. Anywhere you need massive model capacity and fast iterations. So accelerators are mainly already involved in the real world. We know in the future it also one of the play a vital role of the this one. Next we can see the future of the data centers accelerator. Next gen chips NVIDIA Blackwell TPU V6. NVIDIA is the player powerful role of this nowadays. We know, and also it can be provide a more energy efficient AI training, and also AI specific data centers, and also chiplet based design. Like expert more energy efficient chips or make a mix and math components, and also stronger software ecosystem that makes multiple accelerator training easier and efficient time. Cloud providers will keep expanding accelerator instance. Okay, next we can see the conclusion. Accelerators are the backbone of the modern AI training. So they reduce um, training time, enable large modules, and are central to all major advantages in AI. So accelerators play a major role of AI training. It can be AI training can provide a efficient way of the provide a answers and output of the users. Thank you.